All right, so we are doing lesson 6-4. I forgot to change the name on this when I posted it. So this is our notes for, these are our notes for 6-4. And this is going to be our rational exponents. So if you noticed in the problems, these exponents are in fraction form. So did y'all see that when you were looking at, when you were writing them down, that the exponents have a fraction? That's what this lesson's about. So these are rational. Remember, rational just means we have a fraction. It's a ratio. So we're going to see how we switch back and forth from rational form with our exponents to radical form. Radical form is with our roots. So we're going from our exponential, rational exponential form back and forth to radical form. That's kind of a tongue twister. So we're first going to start out in our exponential form with our power. So if I have a base and it's raised to a fraction power, the top number on our fraction is going to represent our power, and the bottom number is going to represent our what? What's the bottom number represent if you wrote that down?
The root.
The root, right. So our top number is our power. Our bottom number is our root. Where do roots go in a tree? Do they go on top or bottom of a tree? They go in the bottom of a tree. So that's how I remember with these fractions that the root is on the bottom, okay? So this is our power, this is our root. So this is written in exponential form. If they ask you to put it in exponential form, this is what they're asking you for. They want you to do the base, and they want you to write it with a power on the top of the fraction, the root on the bottom. Okay, but this is the same thing as the following two ways to write it with a root. This is the nth root of x to the m. So our root is n, our power is m. So the top number corresponds to the power, the bottom number corresponds to the root. Or it could be written with parentheses. You'll see it both ways. I want to make sure that you're familiar with both. It could also be written like this. The nth root of x, all of that to the n. These two are interchangeable. And this is radical form. Okay, so the first part of your assignment is just switching back and forth between the two. So we're going from this form to this form and vice versa. So the first one, we have the cubed root of 7 to the 4th. Can y'all hold your fingers up? What is the base of this problem? It's going to be our big number. When we write it in exponential form, it's going to be 7, right? And we're going to have a fraction power. What's going to go on the top of our fraction, the 3 or the 4? The 4, because the 4 is the power. The bottom of our fraction is the root, and our root was 3. Okay? There's not like a lot of like, why is this true? This is just the way to go from here to here. That's the notation thing. All right? When you have a square root, like we do on number 2, what is the understood number that's outside of the root? Because it's a square root. So what's our understood number out there? You remember for a square root, yeah, Mari, it is 2. So you're going to put a little 2 there if you don't see one. My 2 looks weird. There you go. And now we're going to write this with a base and a fraction power. So what is the base? 6. Okay. What goes on top of our fraction? 3. What goes on the bottom of our fraction? 2. Okay. Thumbs up if we're okay with going from radical form to exponential form. We're just switching the way they look. Okay. All right, we're going to go in reverse. Now they ask us for radical form, so I'm going to go ahead and write my, these are called radicands. I say radicant. Just kidding. That was a bad joke. So what is our base that we're going to put inside of our root? P. Okay. What type of root is this? What's going to go outside of our root symbol? What number is going to go out there? It's going to be a 5. Remember, the root's on the bottom, so that's our root. This is our power. And you can use parenthesis form if you want, or you can just put the 3 with the P. I just like to do that. But almost every time if you're using on your homework, they'll use parentheses on most of them. All right, we'll try number 4. What's going inside of our root sign? What letter? N. Thank you for our sign language. What is our root? What type of root? It is the 4th root. Then we could have put a 1 here. Do we actually really need a first power on the problem? No, you don't need it, but you can write it like that, or it's just the 4th root of n. Okay. Questions between going from exponential to radical form? Power is on the top, root is on the bottom. Okay. The next one that we're looking at, they have it written as a decimal. If you have powers as decimal, you need to switch them into fraction mode. What is 0.25 as a fraction? 1/4, right? So I'm going to replace this 0.25 with a 1/4. And now it's just like what we did here, except we have 10K instead of an N. I'll leave the 10K in parentheses. 4th out there, 1 right there. Okay, we all right with that? Did y'all like this lesson better than the one you just did? 6-3, it's a doozy. All right, number 6, it's the exact same thing. Do we need to really do it? I guess I can work it, write it down. We got 6x, 3 is on the outside, the 2 is here. I know some of y'all just wrote the questions down earlier, so go ahead and write down that answer for you so you can have it. Hey, give me a wave if you're still writing. You need me to wait a second. Y'all good? Okay. All right, on the next ones, we are going to actually evaluate them and simplify, and it's almost always better to do the root first when we're doing these problems. So I do like to use the parenthesis method when I do it. So if they want you to simplify, it's an actual number here. We're going to write it out and then evaluate as we go. Okay, so I'm going to first switch it to a root form, a radical form. This is 8. We have the cubed root of 8. And then we're going to raise that to the first power. I like to write it this way just because it's easier to do. Instead of putting the 1 on the inside, I put it on the outside. Everybody okay with this form, going from here to here? What we just did? Okay. Now we just do what's on the inside first, like we're doing order of operations. What is the cubed root of 8? Remember what cubed gives us 8? Our perfect cubes? 2. Good. So the cubed root of 8 is 2. What is 2 to the first power? 2. Right. You guys can always check these that have numerical values in your calculator. All you do is just type in 8 raised to the 1/3 in the calculator, and it'll give you 2. Or you can use whatever, method you have to get it into a power. You just put 1/3 in the power, it'll give you 2. So you can check those. Let's try for number 8. Anybody think they got number 8 without looking at your paper that you just wrote down? It's 81 to the 1/2. 81 to the 1/2. This is the square root of 81, and then we're going to raise it to the first power. Anybody got an idea? Donovan, what do you think?
You said what? I was picking on my headphone. You said what?
We're trying to figure out this one, 81 to the 1/2 power. So it's the square root of 81 to the first, without looking at your paper that you just wrote down. See if you can figure it out.
So 81 to the, wouldn't it be like the inside of the square root is 81, right?
Yep.
And the outside would be 2. And
yep. That's going to be
a...
So what is the square root of 81?
Uh,
It's more than 8 and less than 10.
more than 8. More than 8.
And less than 10.
Is it 9?
It's 9. Okay, good. 9 to the first. And what's 9 to the first?
9 to the first. When you just put 9 again?
Yep, there you go. So our answer is 9. So we're going to write it in the form, and then we just evaluate what's inside of our parentheses, then raise it to our outside power. Good job. Any questions on these two? Okay, really, if you have a 1 on the top of the fraction, they're just asking you what's the cubed root of 8. Did you kind of notice that? If they have a 2 on the bottom with a 1 on the top, what's the square root of 81? That's really all they're asking if you have a 1 on the top. Now let's do some that have another number on the top. We're going to rewrite 100 to the 3/2. So this is the square root of 100 to the 3rd power. We good with that part? Now we just evaluate the inside and then the outside. What's the square root of 100? 10. We're going to do 10 cubed. And 10 cubed is a 1 with how many zeros? 3. Remember that shortcut with our 10 powers? You just write a 1 with however many zeros. It has the power right there. So 10 to the 4th is a 1 with 4 zeros. 10 to the 5th is a 1 with 5 zeros. Okay.
So what the 2 just disappear?
We did the square root of 100, and that gave us 10.
Oh, okay.
Okay.
And then you just add the 3 over there with it?
Yeah. You just
Basically,
keep that
put it up
3.
there.
Mm-hmm.
Okay.
All right, so now let's try number 10. So we've got the square root of 16, and we're going to raise that to the 3rd. What's the square root of 16? 4. And 4 to the 3rd, 4 times 4 times 4 is 64. Okay, remember, like I said, you can always check these in the calculator or do them in the calculator. 16 to the 3/2, it'll give you 64. All right, occasionally we have to do it twice, like we have a product and we have a power. So just like with your exponent properties, that lesson that you learned, if you have a power outside, you have 2 things on the inside, it's going to have to go to both of them. Okay, so we're going to write this as 81 to the 3/2 times m to the 6th to the 3/2. And we'll deal with them both separately. So I'm going to go ahead and do the 81 to the 3/2 first, just like we did up above. So that is the square root of 81. Then we're going to cube it. And we said the square root of 81, we already said that was 9. And 9 to the 3rd, I think that's 729. Is that right? Okay. So this first part is 729. I'm going to scoot this over a little bit so I can write it right underneath it. Oops, missed the 9. All right, and when you raise a power to a power, what operation do you use? Do you add the numbers together? Do you multiply them together? Do you guys remember a power to a power? We're going to add or multiply. You're going to multiply, right? So we need to do 6 times 3/2 to figure that out. So 6 times 3/2. When you multiply a whole number and a fraction, you multiply the numbers on across the top, and then you put the 1 on the bottom. So what is 6 times 3? 18 over 2. And 18 over 2 is what? It's 18 divided by 2, 9. Good. So when you have a power to a power, you're going to multiply these two numbers. This one will switch into radical form to evaluate, okay? So our final answer is 729 times m to the 9th. So we evaluated this separately, and we multiplied these two to get the 9. If you are not a friend of fractions, then you could just do 6 times 3/2 in your calculator. It'll give you 9. Thumbs up if that's okay. Okay, all right, we'll try number 12. So 64 gets raised to the 1/2. Then n squared gets raised to the 1/2. So I'm going to do them separately. This is the square root of 64 to the 1st. What is the square root of 64? 8, okay? And 8 to the 1st is just 8. What are we going to do with our two powers here, our 2 and our 1/2? What operation do we need to use? Multiply. So 2 times 1/2 is 2 over 2. And what is 2 over 2? 1. So this becomes 8 from here, n to the 1st. Do we really need that 1 there for the 1st? No, it wouldn't be wrong though if you wrote it down. So how did we get this? We multiplied. And this part we wrote as our radical and evaluated it. Are we almost done? That's nice. You're going to have a lot of time to work. Our last two questions, we're not actually switching back and forth from exponential to radical form. This is just simplifying exponents, but your exponents might have a fraction. So it's the same thing that you did in your exponent review, but they're just throwing fractions in there. Okay, so remember within our exponent review, we always dealt with our negative exponents. We moved them first. Then we dealt with our big numbers, our coefficients in the front. We either multiplied them or whatever we needed to do. And then we combined letter by letter. So if you haven't watched the exponent review video, you need to do that. But negative exponents go on the bottom. So on 13, do we have negative exponents that we need to move? Yep, the y squared is going to go on the bottom. I'm going to rewrite it down here. So we have 2x to the 3/2, x to the 3/2, y to the 3rd, over y to the 2nd. When you move an exponent to the other side of the fraction bar, if it was negative, it becomes positive. Is 2 the only constant, or can we combine our coefficient, or we combine it with anything else? Is it the only one? It's going to have to stay a 2, right? There's no other coefficient to simplify with. And now we go in alphabetical order. We're going to start with our x's. I have 3/2 and 3 more halves. How many halves does that make? 3/2 plus 3/2 makes how many halves? Yeah, so we're going to have x to the 6/2. And we'll simplify that in a second. And I've got 3 y's on top, 2 y's on bottom. How many are going to cancel out? 2 will cancel out, and I'll have how many left over? 1. Is it on the top or the bottom? It'll be on the top. Okay. So I'll have 1 y left on the top. I don't even need my fraction bar any longer. It says we don't want fraction exponents at all. Okay, if we can stop with it. So what is 6 divided by 2? 3. Okay. So our answer is 2x to the third y. Remember, if exponents are on the same level, we add them together. 3/2 and 3/2 makes 6/2. Remember, if fractions aren't your thing, you could just put 3/2 plus 3/2. Almost done. On 14, do we have any negative exponents? Nope. Okay, do we have more than one coefficient? Yep, I've got a 4 and a 2. What is 4 times 2? 8. So this 4 and this 2 is going to turn into an 8. Okay, and now I'm going to write exponents next to each other that are similar so that they're close and I don't have to do quite as much with my looking around. So I just rearranged it. So I've got x to the 1/2, x to the 1/4, y to the second, and y to the first. I always write the 1 just so I don't forget that I have to add that in there as well. So for our x's, we're going to go in alphabetical order. We'll do them first. I have 1/2 plus 1/4. What is 1/2 plus 1/4? 3/4, right. This is one that you could do. I have it drawn on that picture if you saw it. I have a circle. I have a half of a circle. I add that to a fourth of a circle. And that makes 3/4 of the circle, doesn't it? Yep, so 1/2 plus a fourth is 3/4. Again, you can do that in the calculator. I don't care. All right, and then our y's. How many y's do we have total to finish this off? We've got 3. 2 plus 1 makes 3. Okay. So that is all from this lesson. It was also a good exponent review as well. For that, let me hit stop record.